In this video, we're going to complete the KutaSoftware Infinite Algebra 2 free worksheet, the Binomial Theorem. Now, before we jump into this worksheet, let's go over what that binomial theorem is. So the binomial theorem says that a plus b raised to a power of n, so in this case a plus b is our binomial, and we're raising it to a power of n. That's going to be equivalent to the summation, so the symbol is sigma, so sigma notation, the summation from k equals 0 to n to that power of n choose k times a to the n minus k times b to the k. So again, n is the power that our binomial is raised to, and k is going to be the index that we're currently at. And a and b are those terms within that binomial. So in numbers 1 through 6, we're going to be finding each coefficient described. And the coefficient of x squared in the expansion of 2 plus x to the 5th. So this is our a plus b to the n. So n is 5, b is x, and a is 2. We want to find the coefficient, so the number that's multiplied by x squared. So if a is equal to 2, b is equal to x, and n equals 5, looking at our formula, I want to see when this is b squared. So I'm going to write this out when I have a k value of 2. So as opposed to summing everything up to get that binomial expanded all out into a polynomial, I'm just going to look at one term and I'm going to find the coefficient of that one term. So I'm looking when k is equal to 2. So using this chunk of our binomial theorem, that's going to be 5 choose 2 times a, which in this case is 2, to the n minus k. So again, that's going to be 5 minus 2, all times by b, which is x, and then that's going to be squared, because we're doing this for a k value of 2. So if I'm curious what my coefficient of x squared is, it's going to be this number when I actually compute what this is equal to. Now 5 choose 2, what exactly is that? 5 choose 2 is a combination, and that formula for n choose k is going to be n factorial over k factorial times n minus k factorial. That's what n choose k is equivalent to. So in our case, 5 choose 2, we have 5 factorial over 2 factorial times 5 minus 2, that factorial. So writing this out, I'll go ahead and get rid of some of this extra space here so that we're not confused by all these extra words. Writing this out, 5 factorial is 5 times 4 times 3 times 2 times 1, and that's all over 2 factorial, which is 2 times 1, times 5 minus 2 is 3 factorial. So then that's multiplied by 3 times 2 times 1. Note that 3 times 2 times 1 cancels out with 3 times 2 times 1. So we have 5 times 4, which is 20, over 2 times 1, so 20 over 2, that's going to give us 10. So right now we have 5 choose 2, which is 10 times 2 to the third. And 2 to the third is going to be equal to 8. So this is going to be 10 times 8 times x squared, which is 80x squared. So for the case of number 1, where we're finding the coefficient of x squared in that expansion of that binomial, our coefficient is 80. So 80 is our solution, our coefficient of x squared in number 1. Now I'll be completely honest with you, memorizing this formula and doing out this work is going to be very tedious. So let me show you a trick. It might take a little bit to explain, but it's going to save you time in the end on this worksheet. And the trick I'm going to show you is by using Pascal's triangle. So I've already laid out the triangle off to the side of my page So if you want to, write it on the back of your page or in your notes section. But Pascal's triangle starts out with 1. So 1 will move to this position and 1 will move to that position. So notice that my 1 will continue to carry through if I follow that diagonal. Same on that right-hand diagonal as well. Now the numbers in between get added. So 1 plus 1 is going to give me 2. 1 plus 2 is going to give me 3. 2 plus 1 is also going to give me 3. 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. And then we'll do another row. 1 plus 4, that will give me 5. 4 plus 6, that gives me 10. 6 plus 4 is 10. And again, 4 plus 1 is 5. And this will continue on as long as you want to go. However, each of these rows represents what gets multiplied to a to some power and b to some power within our expanded polynomial. So each of these rows represent different powers. So we start with n equals 0, then we move on to n equals 1. So this row is a degree of 1, then a degree of 2, 3, 4, and for the sake of this worksheet, I don't believe we go above a degree of 5, so we'll stop it at this row, n equals 5. Now the other nice thing about this triangle is that we can use it just filling in a's and b's. So 1 will get multiplied by a to the 0 times b to the 0. To a degree of 0, we have 1, a to the 0, b to the 0, which is just going to be equal to 1. Now for a degree of 1, we start with a to the first and move as we go to the right in our triangle to a to the 0, whereas b goes that opposite direction. We'll start with b to the first on the right-hand side and move to the left, going towards b to the 0. So when we have a degree of 1, we have 1 times a to the first, b to the 0, plus, because we're adding in between our terms, 1 times a to the 0, b to the first. Well, you can see that's just going to be a plus b, which is true when we have a plus b raised to a degree of 1. And 1 is also true when we have a plus b raised to a power of 0. So just to make this a little more clear, I'll write that out. This is going to be a plus b raised to the 0. This is going to be a plus b raised to the first. Remember, a gets smaller as we move to the right and b gets larger, whereas if we're going right from left, b gets larger and a gets smaller. So we'll have a, b, a, b, a, and b. So starting with 0 on the left for b, we'll go 0, 1, 2, and then a starting on the right with 0, 0, 1, 2. Or you can know that n is going to be your greatest exponent, so we know that a was starting with 2 and working down. So that's going to be 1 a squared b to the 0 plus 2 a to the first b to the first plus 1 a to the 0 b squared, which equals a squared plus 2ab plus b squared. And that, again, is a plus b squared expanded out. So starting with a degree of 3 for a, we have a cubed, a squared, a to the first, a to the 0. And for b, we'll start with b to the 0, go to b to the first, b squared, and then b cubed. Writing this out, 1a cubed b to the 0 is a cubed, plus 3a squared b, plus 3ab squared, plus 1 times a to the 0 times b cubed, which is just b cubed. This is a plus b cubed expanded out. Now, if you get the pattern, feel free to fast forward, but I'll go through this a little more quicker now. So starting with a degree of 4, we have a to the 4th, a cubed, a squared, a to the first, a to the 0. Then working right to left, we'll do b to the fourth, b cubed, b squared, b to the first, b to the 0. So this is going to be a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. And again, that's when we expand out our binomial, a plus b to the power of 4, or to the 4th degree. And lastly, we'll do to a 5th degree. So a to the 5th, a to the 4th, a cubed, a squared, a to the first, a to the 0, b to the 5th, working right to left, b to the 4th, b cubed, b squared, b to the first, b to the 0. So that's going to be a to the 5th plus 5a to the 4th times b plus 10a cubed b squared plus, now it's going to be 10a squared b cubed plus 5ab to the 4th plus b to the 5th. And this was a plus b to the 5th expanded out. Now, if you remember from number 1, looking back at that number, we had to find the coefficient of x squared in the expansion of 2 plus x to the 5th. Here's our a, here's our b. We wanted to find everything that was with this b squared. So this is our polynomial to a degree of 5, going to where b squared is, which is this number here. 10 was what we got for that combination, that n choose k. So that's 10 times a, which is 2 cubed times x squared. There we go, 80x squared. So see, even though it was a little more work to set up this triangle, it's going to be a lot quicker when doing out these problems. So let's go ahead and go to number 2, referring back to this triangle as needed. So in number 2, it wants the coefficient of x squared in the expansion of x plus 2 to the 5th. Now notice the only thing that's changed from number 1 is that my a term and my b term have switched. So if I'm looking for the x squared coefficient when I'm dealing with x plus 2 to the 5th, well, my a is x, so I'm going to look for that coefficient of a squared, which is my x squared. So going into my 5th degree expanded polynomial, here's my a squared term, 10a squared b cubed. So that's 10x squared times b, which is 2, cubed. Again, we're going to have 80x squared, so my coefficient is 80 in number 2. Because 2 cubed is 8, 10 times x squared times 8 is 80x squared. So 80 is that solution. Let's move on to number 3. In number 3, we're going to do the coefficient of x in the expansion of x plus 3 to the 5th. So looking at x, I'm looking for that degree of 1. And that's a degree of 1 when my a is raised to a degree of 1, because x is equal to a, or a is equal to x in the case of number 3. So scrolling back over to our triangle, looking at number 5, when does a 1? That's in this case right here. Or if you're looking at that expanded form, this case here. So 5a b to the 4th. So filling that in for this problem, we have 5 times x times 3 to the 4th. So that's going to be 5 times x times 3 to the 4th, which 3 to the 4th is 3 squared times 3 squared, 9 times 9, that's 81. And 5 times 81 is going to be 405. So we have 405x. So 405 is that coefficient. So 405 is our solution. For number 4, we're looking at the coefficient of b in the expansion 3 plus b to the 4th. So this is a plus b to the 4th, where b is equal to b, our in value is 4, and 3 is a. So we're looking when the coefficient of b, which is b, with a degree of 1, what's that coefficient? So going over to our triangle, looking at our 4th degree, we're going to try to find b to the 1st, which is right here. So that's going to be 4a cubed b. So writing that down, 4a cubed b, now just filling everything in. 4, a is 3, so times 3 cubed times b, which b is equal to b. That's going to be 4 times 3 cubed is 27 times b. 4 times 27 is going to be 108. So 108 is the coefficient of b. So 108 is our solution in number 4. Moving on to number 5, it's getting a little bit trickier. We're going to find the coefficient of x cubed y squared. So if we're looking, our a value is x, our b value is a minus 3y. So when I do a plus b, that b is negative, and our in values to the 5th. So I'll write this one out. A equals x, and b equals a negative 3y. Because our form is a plus b, when we're subtracting, that's going to be a negative b. So I just need to see when y is squared, so this is when b is squared, and a is cubed. So a cubed b squared is what I'm looking for with a degree of 5. So going to my triangle, when n is equal to 5, I'm looking for a cubed b squared, which is 10a cubed b squared. So again, that's 10a cubed b squared, and now I'm going to fill everything in. So I'll have 10 times a, which is x, and that a is cubed, times b, which is negative 3y, and that's squared. So I have 10 times x cubed times, this squared can be distributed to negative 3 and y. So that's negative 3 squared times y squared, which is going to be equal to 10 times x cubed times negative 3 squared is going to be a positive 9 times y squared. 10 times 9 is 90, so this is going to be equal to 90x cubed y squared. Therefore, my coefficient of x cubed y squared in number 5 is 90. 90 is my solution for number 5. Now quickly, moving on to number 6, just to finish out these instructions, we're going to be finding the coefficient of a squared in the expansion of 2a plus 1 to the 5th. Now this is going to be a little confusing because for the form of a plus b to the 5th, this a is actually really 2a. But when it's squared, that exponent is still going to be 2 with a. So within our 5th degree, or our n value of 5, within that row in our triangle, we're looking for an a squared, which occurs right here, 10a squared b cubed. And again, I'm looking in this row where n is equal to 5. If I go over to my polynomial expansion, that's going to occur not where I previously had circled in yellow, but 10a squared b cubed. Again, that's 10a squared b cubed. So filling everything in, we have 10 times our a, in this case, is actually 2a. So 10 times 2a squared times our b is 1, so that's 1 cubed. So this will become 10 times 2a squared is going to be 2 squared times a squared, and 1 cubed is just 1. So this is going to be 10 times 2 squared is 4 times a squared, which we get 40a squared. So 40 is that coefficient in number 6. Let's move on to our next set of directions. And these directions will apply for numbers 7 through 10. We're going to be finding each term described. So no longer the coefficient, we want that entire term. So we're looking for the second term in the expansion of y minus 2x to the fourth. So if we go over to our triangle, or better yet, just for this one, let's go back to our binomial theorem. That's the summation from k equals 0 to n of n choose k times a to the n minus k times b to the k. Now going to a second term, remember k equals 0 will be the first term, so k equals 1 will be our second term. This is our first term, k equals 1 is our second term. So plugging in a k value of 1, we get n, which in this problem is 4. So 4 choose 1 times a to the 4 minus 1 times b to the 1, or b to the first. And again, that was just me filling in n and k within my summation, but I'm just looking at when k is equal not to 0. I just want to see what it is when k equals 1. If I wanted to, I could write out k equals 0, k equals 1, k equals 2, k equals 3, k equals 4, summing all of those together. But in this case, for just finding the second term, I only care when k equals 1. And 4 choose 1 is going to be 4 factorial over 1 factorial times 4 minus 1 factorial, which 4 factorial is 4 times 3 times 2 times 1 over 1 factorial, which is 1, times 4 minus 1 is 3. So 3 factorial is 3 times 2 times 1. 3 times 2 times 1 cancels out with 3 times 2 times 1 to leave me with 4 over 1, or 4. So this is 4 times a to the 4 minus 1, which is a cubed, times b to the first, or times b. And we can confirm this term with Pascal's triangle with the little extra that we added for the a's and b's. So when I have a degree of n equals 4, here's my first term, and here is my second term, moving left to right. And those get added together, remember. So I have 4a cubed b, which is exactly what I got in number 7, using my binomial theorem formula. So 4a cubed b, well, our binomial theorem is in the form of a plus b to the n. So our a value is equal to y, and our b value is actually going to be a negative 2x. So filling that in, we'll get 4 times y cubed times negative 2x, which simplified down is going to be negative 8y cubed x. Negative 8y cubed x is my solution in number 7. Now in number 4, let's just continue to use that triangle for help. If you want to, feel free to use that formula. But Pascal's triangle really helps us just figure out that n choose k, and then we filled in the powers of a and b for each of those n choose k's. So in the fourth term of our expression, to the fourth power, I'm going to go over to my degree of n equals 4, and I'm going to go to the fourth term. So this is the first term, second term, third term, fourth term. So my fourth term is 4ab cubed. Now note, this 4 is whatever I would get if I plugged in choose k. So 4ab cubed, where my a is equal to 4y, my b is equal to x. So 4 times 4y times x cubed, that's going to be 16yx cubed. That's my solution for number 8. In number 9, I'm looking at the first term in the expansion of a plus b to the fifth. And the nice thing about this first term, we're in the form of a plus b to the fifth, and that first term is always our a to the fifth, because it's multiplied by 1 and b to the 0. So our first term, again, is going to be 1 times a to the fifth times b to the 0, which in this case is just a to the fifth. This 1 was our n choose k. So n was 5, so that's 5 choose 0. A to the 5th times b to the 0. So again, that n choose k is what helps us get those numbers within our Pascal's triangle. So for number 10, we're going to do the second term in the expansion. So that second term is when we have a k value of 1. Just as our first term was when we had a k value of 0, our second term was when we have a k value of 1, and this is to the 4th. So the second term for a degree of 4, our first term is 1a to the 4th b to the 0. Our second term, when k equals 1, is 4a cubed b. So 4a cubed b, where a plus b to the n is the form we're using. Now you can see that a is going to equal y, and b is going to equal a negative x. So this is going to be 4 times y cubed times negative x, which is negative 4y cubed x. That's our solution for number 10. Now here comes the fun part. For numbers 11 through 16, we're going to completely expand out these binomials. So 2m minus 1 to the 4th. Remember, we want the form a plus b to the n. So we know our n is equal to 4, our a is equal to 2m, and our b is equal to a negative 1. So when I'm looking at an n value of 4, I'll scroll over to my triangle, or I can use the binomial theorem, summing every single one of those out, starting at k equals 0, adding that to k equals 1, adding that to k equals 2, and so on all the way up to 4. But let's just use our triangle since we already built it. So if I'm summing everything in my row where n equals 4, that's going to be a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. So let's go ahead and transfer that over, because that's equal to a plus b all raised to the 4th expanded out. So again, writing this out, a plus b to the 4th is going to be equal to a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. Now filling this in for my a's and b's, I'll get 2m to the 4th plus 4 times, our a is 2m, that whole quantity cubed, times negative 1, that's b, plus for 6a squared b squared, that's going to be 6 times 2m, that quantity squared, times b squared, negative 1 squared, plus 4 times 2m times negative 1 cubed, plus negative 1 to the 4th. Now I just got to simplify. 2m to the 4th, that's 2 to the 4th times m to the 4th. 2 to the 4th is 16, so that's 16m to the 4th, plus 4 times 2m cubed times negative 1. Well, 4 times negative 1 is a negative 4, but we still have to deal with this 2m cubed, which is 2 cubed times m cubed. 2 cubed is 8, so 8 times a negative 4 is a negative 32. So as opposed to adding, I'm going to subtract 32, and that was all multiplied by m cubed. Then I'm adding that to 6 times 2 squared times m squared times negative 1 squared. So 6 times 2 squared is 6 times 4, which is 24, and I'm multiplying that by a positive 1. So 24 times m squared, and then 4 times 2 times negative 1 cubed is going to be negative 8, so I'm going to subtract 8, and that's multiplied by m, and then I'll add that to negative 1 to the 4th, which is a positive 1. So that's my solution in number 11. 16m to the 4th minus 32m cubed plus 24m squared minus 8m plus 1. Now let's go on to number 12. In number 12, we're expanding out something where n is a degree of 3, my a value is a positive x, and my b value, you'll note, is a negative y. So let's scroll over to the triangle to see where n equals 3. And that's going to be this row here. So I already expanded it out over here, so let's scroll over. That's a cubed plus 3a squared b plus 3ab squared plus b cubed. That's a plus b cubed expanded out. So going back and writing that in, a plus b, that quantity cubed, is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Now all I gotta do is fill things in. A is x, so that'll be x cubed plus 3 times x squared times b, which is a negative y, plus 3 times x times negative y squared plus a negative y cubed. So that's x cubed for that first term, plus my second term is going to be a negative 3x squared y, so I'll subtract 3x squared y, and then I'll add 3xy squared, and then I'll subtract y cubed. So x cubed minus 3x squared y plus 3xy squared minus y cubed. That's number 12. Now for number 13, I have an n of 5. So I'm going to have to expand out a plus b to the 5th, which I've already done nicely using the triangle for some help. So in that last row of my triangle I completed, I just have to sum all of these parts, which I've done over here already. So I'll just copy this down. So that's going to be a to the 5th plus 5a to the 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4th plus b to the 5th. Now for this, my a value is equal to x to the 4th and my b value is equal to negative y. Let's go ahead and fill this in. X to the 4th to the 5th plus 5x to the 4th times negative y plus 10 times x to the 4th cubed times negative y squared plus 10 times x to the 4th squared times negative y cubed plus, I'm running around a room, hopefully I can fit this in, 5 times x to the 4th times negative y to the 4th plus b, which is negative y, all raised to the 5th. Whew, barely got it. So x to the 4th raised to the 5th, remembering those exponent rules, I'm going to multiply my exponents. So that'll be x to the 20th plus, this would be negative 5x to the 16th y, or as opposed to adding a negative, I'll just subtract 5x to the 16th y plus this negative y squared would become a positive y squared. So I'll have 10 times x to the 12th y squared, and then I'm going to subtract 10x to the 8th y cubed. Then I'll be adding again because that negative y is to an even power, so it'll become a positive y to the power. So it'll be 5x to the 4th y to the 4th. And then lastly, I'm going to be subtracting y to the 5th. That's my solution in number 13. Now number 14, again, I'm expanding a binomial to the 5th degree, which we know that pattern right here. So I'm just going to rewrite that pattern in number 14, so I don't have to keep scrolling back and forth. So we have a plus b to the 5th. That's going to equal, and I'll go ahead and fast forward this part so you guys don't have to worry about it. All right, here we go. So my a in this case is equal to 2x cubed, and my b is equal to 1, which makes this b very nice because b, when it's equal to 1 raised to any power is simply 1. So this is going to be a to the 5th, which is 2x cubed raised to the 5th, plus 5 times a to the 4th, so 2x cubed raised to the 4th times 1, but I'm going to leave that out. Then I'm going to add that to 10 times my a value, which is 2x cubed, that's going to be cubed, and b squared, 1 squared is 1, plus 10 times my a squared is 2x cubed squared, b cubed, 1 cubed is just 1. Then I'll add that to 5 times a, which is 2x cubed, times my b value, which again is just 1 to the 4th, which is 1, plus 1 to the 5th, adding that 1. So simplifying this down, 2 to the 5th is going to be 32. So this will be 32 times x to the 3 times 5, which is x to the 15th, plus 2x cubed to the 4th. 2 to the 4th is 16. 16 times 5 is going to be 80. So this will be 80 times x to the 3 times 4, which is x to the 12th, plus 2 cubed is 8. So again, I'm going to have 80, and this will be x to the 3 times 3, which is x to the 9th, plus 2 squared is 4. So this will be 10 times 4, which is 40, x to the 3 times 2, which is x to the 6th, plus 10x cubed plus 1. Now this theorem is really helpful because could you envision expanding this entire polynomial out? You would have to do 2x cubed plus 1 times 2x cubed plus 1 times by itself again, again, and again. That would be so many different FOILs and distributions, it would take a while. But this formula consolidates it and makes it pretty easy. So let's move on to 15, that second to last problem. Whew, and we're back down to some easier ones with just a value of 3. Now remember, I already wrote an in value of 3, expanded that out, back up in, number 12, here we go. A cubed plus 3a squared b plus 3ab squared plus b cubed. So I'll just rewrite that for you really quickly and I'll speed it up. All right, here we go. Our a in this case is y, and our b in this case is a negative x squared. So we'll have y cubed plus 3 times y squared times negative x squared plus 3 times y times negative x squared squared plus negative x squared cubed. So this is really critical to remember those exponent laws. Y cubed is just y cubed plus 3y squared times negative x squared. I'm going to subtract a positive 3y squared x squared. Then I'm going to be adding that to a negative x squared squared is going to be a positive x to the 4th. So I'll just have 3y x to the 4th, and then a negative x squared cubed is going to be a negative x to the 6th, so I'll subtract x to the 6th. That's my solution for number 15. Now finally, the last problem on this worksheet, number 16, which again is to a degree of 3. So writing that out one more time, a plus b cubed is going to be this, where a is equal to y cubed and b in this case is equal to a negative 4x. Now I just got to fill those into that formula. A cubed is y cubed cubed, because my a is y cubed and I'm cubing it. And then I have 3 times y cubed squared times b, which is negative 4x, plus 3 times y cubed times b squared, negative 4x squared, plus b cubed, which is negative 4x, that quantity cubed. Y cubed cubed is y to the 9th plus, or actually I'm going to subtract because this term is going to be negative. Negative 4 times 3 is a negative 12, so I'm going to subtract 12 times y to the 6th, because y cubed squared is y to the 6th, times x, plus this term will be positive because a negative squared is positive. So 4 squared is 16. 16 times 3 is a 48, so that's 48y cubed x squared. And then lastly, I'm going to add negative 4x cubed, which will be subtracting 4 cubed x cubed, which 4 times 4 is 16, and 16 times 4 is 64, so that's 64x cubed. Y to the 9th minus 12y to the 6th x plus 48y cubed x squared minus 64x cubed. That's my last solution on this worksheet. Hopefully you found this video helpful. If you did, give me a thumbs up. So go ahead and like, subscribe, and share. If you have any questions, leave them in the comments below. If you need help with factorials, I've got a video on that. If you need help with summations, I'll post a video soon on that. So sigma notation, feel free to look at that. And hopefully you learned that new trick using Pascal's triangle for this binomial theorem. So as always, don't forget to like, subscribe, and share.